Hello. We're here to talk about Foxborough Evo and how the Foxborough Evo system can serve the operator. We have three primary problem statements that we're helping the operator to accomplish. The need to quickly handle abnormal situations, the need to reduce operational error, and the need to control the plant at peak performance. Let's take a look at what we're doing at the HMI level to help the operator be successful. Marcel.
What we see in existing plants is displays like this one. We visualize the plant, we visualize a P&ID scheme, and we use all the nice features that we have in our technology to show cosmetics like this beautiful valve, like a three-dimensional display of the reactor of the plant equipment, and we use color. Now the problem is that this information really doesn't help the operator, it just decorates what we show on the screen. So for example, if you see these numbers here, they tell you data, this is data, but it doesn't tell you any information. You don't see if your plant is running good, if your plant is running bad, if you're close to a trip, or if the relation of these two values to each other makes sense or not. And looking to an overview of a plant, we have the same problem when we go to the old overview that shows more than one reactor. We always have the challenge to show a context of where the plant is actually running at. But we do this with just showing the information and not having really the information about where are we currently doing. And in addition to that, we see when we go to performance displays, again, high-level information, but how difficult it is to tell if we are doing good or not with this display.
Thank you. So we've made some investments in our technology, but even more importantly, we've made investments in our personnel and how to create more optimal displays and improve the user experience with operators so they can be more successful in accomplishing these business goals that we've explained. So Steve, could we look at what can we do to make the reactor HMI experience even better than what we showed earlier? So there's a number of facets around the HMI that we've improved to help the operational experience. Firstly, we still have a piping and instrument diagram like HMI to show the operator how the process works. But we've done some other interesting things. As Marcel indicated, one of the problems with the previous display was we just showed numbers, and that's nice, it's real-time displays, but there's no context of whether those numbers are in an optimal zone. So one of the first things that we have is the ability to show an optimal zone. So symbolically, the operator can tell just by looking at this display that the process value is within an optimal zone. The same display also shows him the alarm limits, so he can see excursions or if they're going to approach closely to these alarm limits. So around the topic of alarm optimization, it's better that operators are given enough visual prompts to stay away from alarms or alarm limits as opposed to exceeding those thresholds and creating an alarm shower of some description. Steve, if we could just zoom back out to the overall display. So there's another interesting aspect with this redesigned version of this reactor HMI. One of them is, as Marcel indicated, those values. How do we know if those values have the correct relationship to one another? Well, in the old days, operators had panel board instruments, and they could tell if the set process variables were in the right place just through pattern recognition. So we're simulating a similar effect with these profile lines so that operators can recognize that these process variables have a distinct relationship to one another, which is going to set up for optimal presentation or optimal control. We can take this concept even further. Rather than just showing them lines of process variables that are linked together, we can represent these symbols as a polygon, as an animated polygon. So we have 4 distinctly separate variables. When those variables have the most optimal relationship to one another, they will form a regular polygon. But if any of these variables exceed or stray from an optimal value, then we start to see the polygon getting a wee bit funky. So the whole idea with this part of the diagram is, without any special techniques, the operator can immediately see at a glance that his process is operating within an optimal zone. The next facet of this display, again, moving away from just showing the digital data, we're also using a technique called trend tails. So these trends here are not used for detailed process and analysis. It's simply to indicate what direction process values are moving to. Are they trajecting to an optimal value, or is it moving quickly away from the value? This allows operators to anticipate problematic process reactions so that they can keep it within a more optimal zone. Steve, so let's take another look at another facet of the HMI and talk about alarms. So one of the more interesting aspects of this design concept is the lack of color. This is very intentional. We don't want to have gratuitous animations or colors that could distract the operator from identifying abnormal situations. So when a process variable actually exceeds an alarm limit, this is the only time that you get to see us invoke color. Firstly, we are showing the alarm in a specific area associated with the value that's exceeded its threshold. We're showing a color that is indicative of the alarm priority, as well as a symbol which includes a shape and a number, which also communicates to the operator the priority of the alarm. Steve, if we could pop out to the overview display. So when the operator looks at a more holistic view of his HMI, he can look at the entire plant overview, and he can see that this alarm has occurred, and pointing the way to where the alarm, or the relevant process area where this alarm is relevant. The other aspect of this is that the alarm is aggregated into his dashboard so that he can see the highest priority alarm is being aggregated, allowing him to drill down, and let's just click on that one, to really identify the root cause of why this is an issue. So Marcel had spoken earlier about overview displays. We're very accustomed to creating an HMI experience that talks about P&ID diagrams and other things. But what happens when we get to the level 1 displays, which is the overview? So using a situational awareness concept for graphics, we're able to create an overview display that gives the operator total oversight of what's going on. We're able to combine the techniques that I've mentioned, trend tails, animated polygons, as well as other techniques for representing the overall performance of the plant in general. What else are we going to talk about? So we also talk about helping the operator maintain the plant or operate the plant accordance to peak performance. And many times, or many occasions, we want to make sure that the operator is given the right procedural guidance, that he's doing the right things. not just when the plant is running at steady state, but when he's starting the plant up or shutting the plant down. So one other concept that we're delivering here with our HMI experience is to give him the visual cues of the procedure that he's required to do to operate and start the plant up and shut the plant down. By giving him these visual cues, it helps an operator to accomplish these operations either if he's on the morning shift or whether it's another group of operators that are operating in the night shift. They're able to do and operate the plant consistently because we've provided them this visual cue. So, in summary, if we combine all of these techniques together, we're able to help him identify abnormal situations, making sure that he only is drawn to those areas that need attention. We help him to reduce operational error by focusing on those areas that are important. And we allow him to maintain and run the plant at peak performance by giving him visual cues that tell him, if we could go to level 1 display, Steve. Yep. By telling him, by focusing on those areas that are important, and we allow him to maintain and run the plant at peak performance by giving him visual cues that tell him, if we could go to level 1 display, Steve. Yep. By telling him that this is a good zone. So we're able to give him and show him those visual cues that allow him to run the plant at peak operational performance. Please come and visit us at our X-ray stand, focusing on the operator experience. Thank you.